Hello, so we finally made it onto phase 3 of the code. I'm going to split this into probably 2 or 3 videos, otherwise it's going to become too long. The main changes within phase 3 from a file point of view is I've added a memconfig section and an addressing mode section. The memconfig section allows me to create elements within the array, and those elements are maintained between compilation, because obviously using the insert routine in here doesn't maintain those changes, between quits and things. So it's very difficult to keep integrity between your testing phases. The addressing mode section, AM is addressing mode, and then you've got the type of addressing mode. So there's 3 written in this section, the others aren't written just yet. And the immediate, zero page, and absolute, they were covered in a previous video, so we've actually started to implement those. And within the instructions, we can see that the AND instruction here, which is one of the first ones I wrote, has actually got those references to those. So it uses the shortcut method there for ANDing, so it ANDs whatever's in the CPU address register, the CPU A register, the accumulator, with whatever is passed back by this function. Same here and same here. The other instructions that I wrote were the jump and the JSR. Now the jump was one of the first instructions that I wrote, because it's actually quite an easy instruction to write. So in terms of the code, that code is pretty much the same as the code that's in the absolute here, because it was fairly much a copy and paste. So what I did was, once I'd tested the code, once I'd written the code inside of the instruction, I then decided that actually probably needed an addressing. I needed to change it a little bit, and added the addressing mode file, and that then this is how it sort of matured. Really, I suddenly realised that I was going to end up with a lot of duplicated code. The obvious exception is this, because within the 6502 instruction set, there's only the jump instruction that actually uses the indirect addressing mode. So this code might as well stay here, because there's no need to create a separate function, as the jump instruction is the only instruction to use it. And the JSR instruction, actually I'll go through the JSR instruction in more detail in a separate video, as I will with the AND instruction, because there's a little bit to them, and once it's kind of clear how I did this and why I did this, then the rest of the instruction set will become quite easy to understand. Within the, what else did I do? Yes, within the header file, it became clear that a lot of the instructions don't need their own routine. So the reg instructions there, and the, what have we got up here, the flag instructions, they got concatenated. So instead of having all these instructions that dealt with flags, for example TAX and TXA and so on and so forth, the instructions here and there and there and there, all of these became one routine, and that can be sort of seen quite clearly in the main instruction.c file. And again here, look, these use are not and, as we described in the previous video, or. So to clear something, we use the not and to set it, we use the or, and that's also used inside of our main code here. To the exclusive for is used to toggle, flip the bits, and that can be demonstrated. So if you see what we've got on default is the status register is set pretty much to all zeros, with the exclusion of the bit that we can't play with, which is supposed to be set to 1 according to the 6502 manual. And what we can do is we can toggle, say, the overflow bit like that, and by toggling it we change its status to 1, and we could toggle it again if we wanted to, and that would then set it back to 0, and that uses that exclusive or function we discussed previously. The reason why this was done was because when you're writing instructions, you don't necessarily write the whole instruction in one go. You might write, for example, branch instructions rely heavily on the status register flags to do something. Well, if you can't set those status register flags using any other opcode because you haven't written it yet, then I needed sort of something within the CLI that allowed me to play about with the status register. So I wrote the toggle function. And just as a quick reminder, this is how the exclusive for works. So if we were setting the overflow flag, which is with what we've just done, then we set the bit, this bit here, bit 7, which is 64, and because we exclusive for, well, exclusive for says one or the other but not both. Well, there's nothing set there. There is one there. There is one there. No, no, no. Yes, yes. And that, and that sets it. Now, if on what would happen if they were both set like this, when you did the exclusive for, what would happen is that would get turned to 0 because it says one or the other but not both. So that's how that toggle function works, and that's precisely what you see here. If where's the V? There it is. So if V is set, then exclusive for it with 64, and that's the result. The several other things that happened within the within this main function, mostly within the reset here. So what I did was I set up the accumulator here, the A register to 9C, just to give us something to play about with when we would use testing and I also used the I also set the program counter based upon the cold start jump vector, and the cold start jump vector is in here. So there we go, FFFC and FFFD, and it's set to C000, little endian, and as you can see, that is exactly the case. So things are starting to come together at this point. Within the next video, I'm going to start talking about how the instructions work, and specifically I think we're going to take a look at the JSR instruction, because it's quite a good one to look at, and we can have a look at how that all fits together and what all these kind of things do, and why, and we can start looking at putting together these kind of combination instructions like the OR with a left shift, which is again what we discussed in a previous video, but I think it warrants a bit more work, because once that's explained once, then subsequent videos and subsequent explanations, of what happens within the emulator become quite clear, because it uses this quite a lot, and I don't think there's any harm in sort of spending a little bit of time on it at this stage.